name is Michael, and I'm a Chem121 PLF. Today I'm going to be guiding you through Hess's law problem. So we want to find the delta H for the reaction right here. 3 hydrogen gas plus 2 solid carbon, half oxygen gas, and C2H5OH in a liquid form. And we're given some thermochemical data, the delta H's of each one of these reactions. So basically we want to model each one of these reactions in this form right here. And we see that we have C2H5OH in the products and what we want to achieve, but it's in the reactants in this. So in order to flip this reaction around, we'll multiply that by a negative, and whatever we do to the reaction we also need to do to the thermochemical data. So that's also a -1 times that number right there. Alright, so let's go ahead and write this out now as it's flipped around due to our manipulation. So we have now 2 CO2 in the products, 3 H2O in the products, and that gives us 1 C2H5OH, or reactant, sorry, and the now we have C2H5OH in the products, which is what we want. And we have 3O2 in the products also. So we have 3O2 in the products, and we want to get rid of these oxygen. And we see that these two other equations both have oxygen in the reactants, so we'll have to figure out a way to manipulate that. But since they're not whole numbers completely, I'll skip the oxygen balancing right now, and I'll move on to balancing these hydrogen. Equation 1. So we see that there's 3 hydrogen here in equation 1 that need to be canceled out by 3 hydrogen in the product side for the other equation. And so we'll go ahead and multiply this equation by 3 and also this thermochem data by 3. That's going to give me 3H2 gas plus 3 halves O2 gas, and that'll give me 3H2O liquid in the water product side. Alright, so we can now cancel our water, and that's good. Now we need to cancel our carbon dioxide, and let's see, we also lose 3 halves O2, and we get 3 halves O2 in the product side now. We have 3H2 gas, which is what we're looking for, so let's cancel out our 2 CO2. We'll use equation 2, and we'll multiply equation 2 by 2, and that'll give us a good cancellation between products and reactants. So equation 2 now is 2 solid carbon plus 2 oxygen gas results in 2 CO2, also gas. Multiply our thermochem data by 2, and now we have carbon dioxide canceling out from products to reactants, and we have 3 halves O2 here, which means this would be 4 halves, so our 3 halves cancel out and gives us 1 half. And that leaves us with 3 H2 gas in the reactants, 2 solid carbon in the reactants, and 1 half O2 in the reactants, which is exactly what we want in the reactants for our reaction in the problem statement. And we have 1 mole of C2H5OH in liquid phase in our product side, which is what we want. So now that we know that it's balanced in the way that we want it, or proceeds in the way that we want it, we'll find our total delta H reaction by summing these. So delta H1 was multiplied by -1, that gives me a positive 875 kilojoules. Delta H2 was multiplied by 2, so we'll do 2 times negative 394.51 kilojoules, 789.02, and that's a negative sign. And lastly, we have 3 times negative 285.8 kilojoules. Another negative 8, 57.4 kilojoules. And the sum of those is going to be $875, negative 771.42 kilojoules. And let's see, we've got 4, 4, 5, 3 sig fig. So it looks like, since this is the least sensitive number of significant figures, we're going to retain 3 for our final answer. So delta H reaction is going to be negative 771 kilojoules. Alright, I hope that helps out. Thank you for watching.